All right, so I'm going to go through this problem and you can annotate your copy. You have a completed copy in your Google Drive. You also have a blank copy of this, depending on how you want to work with this. So for chapter 21, you're working with two proportions, either with intervals or with tests. So also in your Google Drive, you should have a completed copy of all the parameters, estimates, conditions. So the ones we're going to be working with are right here. And you'll notice a couple things when we're in the z-test especially. We're going to be looking at what's called a pooled p. So the p hat in this case is not the sample proportion, it's the pooled p. The sample proportions are going to be marked with the subscript of 1 and 2. So if we were doing a confidence interval or a z-test, it's the same conditions that we had before. We just need to add one more where the groups are independent. And when you're looking at the interval, if we're dealing with intervals, you need to make sure that you pay attention to the fact that we are looking here at the difference of the two sample proportions. So that would be our estimate. And then when we're dealing with a z-test, the parameter is the difference in the two proportions, and then the estimate is the difference in the two samples, okay? So that converts to a z-score where you have your data, the difference between the two samples, minus your null hypothesis over your standard error. And remember, your standard error is found right above here. So when I go ahead and look at the problem that we're dealing with, we are trying to see if the idea of having a support group like they are given in group 1 along with a nicotine patch in group 1 is going to be more successful for quitting smoking than group 2 that just has the patch but no support group. So we're looking to see if group 1 has a better success rate than group 2, okay? Because the question here says, do these results suggest it's an effective way to help people stop smoking? So that means that this is going to be greater than, because I want the first group to be greater than the second group. When I go ahead and look at just organizing for communication, I really suggest, especially this year on the AP test, that you show as much as you can with organizing. So this right here is just organization, taking the numbers out of the problem. X is successes and N is sample size. So the first thing I did was write down my null and alternative hypothesis. Usually the null is going to be no difference. So you're going to set that at 0. So the difference is 0. Now, sometimes they will say there's a known difference and you're trying to see if that known difference has changed. Well, then that known difference would be your null hypothesis. So no difference or known difference is going to be your null. I set this one as a greater than because group 1 is the patch and support. So I want this proportion here. I want to see if this proportion is higher than the other one. If it is, I end up with a positive number. That's a number greater than 0. Make sure that you write the words that go along with your hypotheses as well. So for the treatments, you need to make sure that you specifically say that the treatment groups are independent. So that's my first condition. The second condition is that I have a simple random sample and less than 10% of a population, or assignment to groups was randomized. Now, this is an experiment, so we don't have a simple random sample. The people volunteered, but we did randomize their participation. So that will give us the independence condition will be met there for each group. And then you need to make sure that you check both group 1 and group 2 to see that both successes and failures are greater than or equal to 10. That means that the sample's large enough. Once we've done that, we can say conditions have been met to perform a z-test. So we're back to proportions. We're dealing with a z-test, the difference of two proportions. On our calculators, that is going to be stat test number 6, and you can see the output over here is my output for what was entered into the calculator. So the calculator is going to ask you for both x's, both n's, and then it'll calculate for you. And it gives you an output that some of it looks familiar and the other parts may not. So we've got a z-score that's greater than 2. We know our difference is unusual. The next is your p-value. So the one that's just a plain old p, that's your p-value. It's low. It's less than 1%, so we know we're going to reject the null. Then you have two sample proportions, so that's the group with the counseling, 32% success, and the group without the counseling, 19.9% success. The last P with the hat but no subscript is your pooled P. That number came from adding up all the successes right here, adding up all the successes and dividing by the total in the whole experiment. And the number given, I've rounded to 0.26. So that number is going to move right here and right here. So for standard error, you're going to put the two together. So the pooled P and the pooled Q over each sample size, they get added up and take a square root. You do not need to figure out that number. You just need to write it down for the mechanics, because what happened is I have my data. So I subtracted my two sample results, that's my data, minus my null all over this standard error right here. And that gave me a z-score of 2.41. The probability that a z-score is greater than 2.41 is 8 out of every 1,000 times that we do this. So that's a very low p-value. We are going to reject the null. I don't even need to state my significance level because that's lower than 10, it's lower than 5, and it's lower than 1%. So we reject the null. There is evidence that a support group, in addition to a nicotine patch, is an effective way to stop smoking. So the next thing I did is I went ahead and I went to stat test B, because the data is already in there, and calculated a 95% confidence interval. So my confidence interval shows me that the true difference in proportions, I'm 95% confident that it's between 2.3 and 22.3% between those two groups. So the group with the counseling can be anywhere from 2% more effective to a little over 22% more effective. So this question was not asked on this problem, but the confidence interval shows all of the interval over here, all of the intervals positive. Okay, so that supports my conclusion that group 1 did have a higher success rate. Now the next one is about comparing bacteria found in name brand versus store brand chicken. And so there are a couple things to note in this problem as you're looking. First of all, they give you this information that they gathered this in 25 US cities. That's going to be important for independence. If they went and bought the chicken all at one store, all in one city, you would not be able to say that each package was independent of the next. But they didn't. They went to 25 different cities. And what we're looking for, they want to know if it's safer to buy the name brand product. So safer chicken would have less bacteria. That's going to come into play when I do my null hypothesis. So the first thing I did, or when I do my alternative, the first thing I did is I need an X value to put into the calculator, and I'm given a percentage. So the first thing I did, just write in the calculator, I did 0.33 times 0.75, okay? And I did that as I was running the test, and it gave me 24.75, I think. The calculator isn't going to handle a decimal there because our X values are counts. So I rounded that up to 25. Same thing with the X value for the store-bought. It was 45% of 75, which was 33.75, I think, and I rounded it up to 34. So the X and the N values are what go into the calculator, and that information you will see over here. Okay, that's my output. So my z-score output is negative 1.5. My p-value is just over 6%. I have two sample proportions, and then I have my pooled p. That's going to come into play with the mechanics. So the first thing you do is set your null hypothesis. There's no difference, okay? It's the null, so there's no difference in bacteria between name and store brand chicken. And then for the alternative of this one, if I'm looking to see if the store brand is safer, okay, the store brand was my first one. Okay, so the store brand is this one right here. If that's safer, I should find less bacteria in it, which means that P2 is going to be a higher number. If I subtract a higher number from that P1, I'm going to get a number less than 0. So there's less bacteria in the store brand chicken will be my alternative hypothesis. So first thing I do is I say these two groups are independent, okay, the store and the name brand. So that's a new condition for two proportions, okay? They are independent groups. Then within the group, we can consider them independent within groups because it was purchased, as I said earlier, in the 25 different cities. Okay. So we can meet that independence there. So you don't want to say it's a simple random sample. You don't want to say it was randomized. This is the context of we purchase them in different places. And then the next part is making sure that my sample is large enough so all of these numbers for successes and failures are greater than or equal to 10. Once again, the conditions are met to perform a z-test for a difference of two proportions. And so when I show my mechanics, okay, remember I've taken all of this just from the calculator output, okay? So the first thing I had was my difference in the sample proportions. Looks like a big difference. It's 12% lower for the store brand. But is that 12% significant? You have to go ahead and figure out with this p-value that we're going to get. So remember, when I was looking at the computer output, I've got this pooled p number, okay, 0.39. I'm going to take that number and put it into my standard error. So 0.39, 0.61, pooled P, pooled Q, pooled P, pooled Q for the second one. And then the sample sizes were the same. So both of those are 75. This 0 right here, that's my null hypothesis, my known difference. So there's no difference there. And I end up with a negative 1.5 z-score, which we know is not unusual. This is the probability, our p-value, that we would get something lower than that. So this one is at 6.6%, so I needed to make sure I mention a significance level, so I picked a significance level of 5%. I would have made the same conclusion at 1%, but a different conclusion at 10%. So I went with 5%. We do not have enough evidence that the name brand is safer than the store brand, so we retain the null. Now, in order to check to see if retaining the null was the appropriate decision, I went ahead and I did a two proportion z interval. That's going to be test B. Okay. And if you look at my number right here, I go from a negative proportion to a positive proportion. So 0 has to be within that interval, which means that it's plausible that there's no difference because 0 is in the interval. So a 95% confidence interval supports my conclusion. 0 appears in the interval, making it plausible that the true difference is 0. So if we end up, just to clarify this a little bit, these negative numbers right here mean that the store brand had less bacteria than, or sorry, the name brand had less than the store brand. But once you head into a positive number, that means that the store brand had less than the name brand. So depending on the sample, it could switch to either one. So we retain the null that there is no difference between the two.